So today we're diving into two data structures that are honestly the unsung heroes of programming. They're called queues and deques, and they're quietly running the show everywhere from your printer to major web APIs. And you're about to see how Python takes what can be a really complex concept and makes it feel like absolute magic.
But first, let's just get this out of the way. Why is Q spelled so weirdly? Seriously, you can take off the last 4 letters and it still sounds exactly the same, Q. It's a funny little bit of English language quirkiness, but hey, it definitely makes the name memorable, right?
And despite that funny name, queues are absolutely everywhere. Think about it. The last time you sent a bunch of documents to the printer, that whole process was managed by a queue. All those little background processes humming along on your computer right now? Yep, that's a queue too. They are a true cornerstone of software, managing task lists, database requests, you name it.
So here's our game plan for today. We're going to start with the basics. What even is a queue? Then we'll look at its core logic, sort of the hard way to build one. After that, we'll unveil the Python magic that makes it all so simple. Then we'll level up to its superpowered cousin, the Deque, and wrap it all up with the key things you'll want to remember.
Okay, let's kick things off with part 1. What exactly is a queue? Well, when you boil it all down, it's really about one simple, very fair principle.
And that principle is FIFO, first in, first out. It's just like they say, jo pehle aayega, wo pehle paayega. Whoever comes first gets served first. It's a rule of fairness we all understand, just applied to code and data.
You know, the perfect way to picture this is a line for movie tickets. The first person who gets there is the first person to buy a ticket. Simple. New people don't just jump to the front, they go to the very back of the line. That, right there, is a queue in action.
Okay, so sticking with that ticket line analogy, let's break down the lingo. The front is the head of the line, right where the next person gets served. In our world, that's where an element is removed, or dequeued. The rear is the tail end, where new people join. That's where we add an element, and we call that an enqueue.
All right, now let's pull back the curtain a little and look at the mechanics behind the scenes. This is super important because it's how you'd build a queue in a lot of other languages, and it's a concept that comes up all the time in technical interviews. To really get it, let's pretend we're working with a fixed size array, like you would in a language like C++ or Java. This means we can't just keep adding things forever. We actually have to manually keep track of where the line starts and where it ends using 2 little pointers or variables for the front and rear positions.
And this is where it gets a little complicated. You start both front and rear at -1 just to show the queue is empty. Then, when you add the very first item, you have to set both pointers to index 0. To add another item, you move the rear pointer, but, and this is key, you have to check if the array is already full first. That's an overflow error. And to remove an item, you move the front pointer, but you have to check if it's empty. That's an underflow error. It's a lot to juggle.
Okay, so you've seen the hard way. Now, get ready for the payoff. Let's see how Python looks at all that complexity and just makes it disappear. This is where the real magic happens.
The secret sauce here is Python's list. It's what we call a dynamic array, which is a fancy way of saying it just grows automatically whenever you add something. All that headache of tracking pointers and checking for overflow, gone. Now, using a list is perfect for learning this, but just a little pro tip, removing things from the front of a really long list can be a bit slow. Python has a better tool for that, but for seeing the magic, a list is perfect.
And I mean, just look at this, side by side. It's night and day. The old school logic has us moving pointers and checking for errors just to add something. In Python, it's just .append. And for removing, forget the pointer math and error checks. It's just .pop 0. So much cleaner.
So building this in Python looks so clean. We'll make a quick class. Inside the initializer, we just create an empty list called self.items. That's it. We also add a handy little helper function, isEmpty, that just checks if the list has anything in it. This is basically our easy underflow check.
And here it is. To add an item to the back of our queue, to enqueue it, we just call the append method on our list. That's it. One line. It automatically puts the new value at the end, exactly where the rear of our line should be. No fuss, no drama. Now, to take something off the queue, to dequeue, we first use that isEmpty function we made. If there's something there, we just call .pop 0. That 0 tells Python to remove the item at the very first position. And what's really cool is Python then automatically shifts every other element down one spot. It's super convenient, but again, remember that shifting can take time if your queue is massive.
Okay, so we've pretty much mastered the queue.
But what if we could make it even more powerful? Well, it's time to level up and meet its more flexible, super-powered cousin, the DQ. A deck, and you pronounce it deck like a deck of cards, stands for double-ended Q. And honestly, it's the perfect name for it. It's a line where you can add or remove people from both the front and the back. Total chaos at the ticket counter, but incredibly useful in programming.
So this basically gives us 4 operations instead of 2. We can add to the front, add to the rear, remove from the front, and remove from the rear. It just gives you a massive amount of flexibility compared to a standard queue.
Now you might be thinking, okay, double the operations probably means double the complexity, right? Well, not with Python. The magic continues, and it is still remarkably simple.
Check out how perfectly Python's list methods map to every single DQ operation. We already know .append adds to the rear and .pop0 removes from the front. But look, to add to the front, we just use .insert 0 value. And to remove from the very back, just .pop with nothing inside. It's so clean and symmetrical.
All right, let's bring it all home. If you're going to remember just a few things from our time today, make it these key points.
So the big takeaway is this. Queues are all about that fair first-in, first-out rule. It is absolutely vital to understand the manual logic with pointers and error checks for your interviews and for a deeper knowledge of programming. But in practice, Python's magic just handles it all with simple list methods. And when you need that extra power, the Deques gives you ultimate flexibility. And remember, while lists are fantastic for learning, for high-performance stuff in the real world, you'll want to use Python's specialized collections.deques object.
And that leaves us with one last, really interesting thought. We've seen a line with one end open, and we've seen a line with both ends open. But what if we connected the back of the line to the front and made it a circle? What kind of crazy new possibilities would that unlock? Well, that's a story for another time. Thanks for joining me.